Okay, hello, dear listener. Today we are going to talk about fire modeling and also smoke extraction for the enclosed car park zone using CFD software. This is common study with Istanbul Medeniyet University Mechanical Engineering Department and also CVS Air Company. In our presentation, we are going to talk about park systems and fire modelings. And also, we are going to give some information about methodology. And then we are going to look at studies and results and conclusion in this presentation. You know, car fires in enclosed car parks, they are a very important issue. Actually, a proper ventilation system, it is required to extract to smoke and reduce temperature. You know, actually, the car park fire affect human health, finances, and environment. So fire smoke, it can flow rapidly through the enclosed area, and this issue means the dangers of fires in these enclosed parks. In this study, we intended to reduce density of smoke in this enclosed area to limit temperature according to standards and also to assist escape points. And second concerning topic is to limit the smoke environment in order to provide clear way for firefighters to intervention to fire. Here you see the methodology. Actually, we used here computational fluid software. It is numerical calculation to calculation method using computer-based simulation tool for the analysis of complex system. And also, it can be used to model to simulate smoke diffusion, visibility, airflow, air quality, and temperature in area in case of fire. In our special case, parking lot was modeled and simulated using this PyroSim fire dynamic simulator software. And also in our methodology, pressure-based solver, it has been defined for steady-state model for this special case enclosed park area. And the volumetric transport model also, it was selected to describe the fire move from a car with the inclusion of diffusion energy source option. For turbulence modeling, we have selected less model, large eddy simulation model to represent our turbulence. Here you see a car park layout 3D model for our special case. This car park geometry model has been designed in 3D dimensional domain, and also we have defined boundary conditions for this closed system. And this space, such as columns and rooms, they were modeled as closed volumes because they would have negative effect on the flow. You need to define your control volume, you know, in these CFD systems. Here you see three-dimensional car park design for our special case. Let's talk about our boundary conditions for this system. Once the closed parking geometry, it has been completely designed in this Pyrosim software. The model also, it is ready to apply the simulation in input data. And parking environment, it is, if you look at the initial condition, we have selected temperature as 20 degrees Celsius, and as pressure, we have selected atmospheric pressure. In a CFD analysis process, boundary conditions, they are, important parameters, and they should be defined in your each model. Here we have 3 important equipments for this closed area. One of them is axial fan, and other one will be jet fan. Here you see. Now you see our axial fan properties, type of our axial fan, and flow rate properties in meter cube per hour, and our quantities. Here in this table, you see the axial fan flow rate value, and also jet fan properties. Again, here we give flow rate, thrust value, and quantities. And here you see heat releases rates for this dimension, perimeter, and heat our equipment. Important issue for this car park CFD analysis, it is the heat release rate, one of the important parameter. The amount of energy released during vehicle fire varies with time, And here in this table, it shows the heat release rates for different parking conditions according to standards. In this study, there is also a sprinkler system in parking lot. So car fire heat release rate can be defined as 4 megawatt to CFD model according to international standards. Here also you see a CFD model with boundary conditions in this layout. 5-point jet fans, smoke exhaust shaft, and also fresh air shaft, and also you see escape points. Okay, we have limited time, I'm gonna pass another slide. Here you see heat release rate as a function of time. You see. Actually, in our mesh modeling, the area of simulation model car park, it is divided into several small cells. The method used by CFD and FDS software, it is to calculate air temperature, velocity, optical density, smoke, and fire emission for each small cell. Dear listener, you see the mesh modeling of our special case in 3-dimensional domain. Here you see selected design, selected size for our mesh generation. Okay, I'm going to pass to results. In our special case, we searched these questions. Does the jet finds they are located in the correct places? And also, is there any dead space in our closed space? And also, is the temperature under the specified temperature in the international standard? So here, smoke diffusion in our special case, temperature gradient, visibility, carbon monoxide mass fraction, and also air velocity gradient, they are all calculated with finite element software. So we can summarize and compare the results. Here you see smoke diffusion results with different time and visibility results. Again, is a function of time, temperature results with time in different space of our car park area, and velocity results you see in meter per second versus time again. Dear listener, in our last presentation, we can summarize as our special case, smoke discharging work successfully is employed, and also visibility at this escape around 5. They are at least 10 meters, which is satisfying the international standard, we can say. And also related with the temperature around emergency exit, we can say it is within the boundaries of these international standards. Again, we can say in our air velocity, if you look at the air velocity, it is at most 3 meters per second if you look at the velocity graph. And also we can say it's acceptable for the international standard. Okay, thank you so much for your listening.